All right, buckle up, everybody, because today we are diving deep, deep into the world of OS detection,
OS detection.
or as some people like to call it, OS fingerprinting,
Oh, yeah, yeah.
which is basically figuring out what kind of computer somebody's using
Yeah.
just by looking at their network traffic.
Yeah, it's kind of like having digital x-ray vision.
Yeah,
You can see the underlying system
right.
without ever actually like seeing the machine.
That's a great way to put it.
Yeah.
And we've got a ton of sources for this deep dive.
Oh, yeah.
We've got technical blogs, we've got security articles,
Yeah.
and even official documentation from the Internet Engineering Task Force, the IETF.
Right. They've definitely given us a lot to talk about.
Yeah, they really have.
It's fascinating stuff.
Yeah,
It's really a blend of the subtle and the complex.
right.
Who knew so much information could be gleaned just from watching bits and bytes flow by
Yeah.
on a network?
So let's start with the basics.
Okay.
What exactly is OS detection?
So at its core,
Mm-hmm.
OS detection is really the art of figuring out
Mm-hmm.
what operating system
Okay.
is running on a computer remotely
Okay.
just by analyzing how it communicates on the network.
Right. So
Every OS has its own little quirks and tendencies,
okay.
like a unique fingerprint.
So it's not just about what data is being sent,
Right.
it's how it's being sent, the little digital mannerisms.
Yeah, exactly, precisely.
Okay.
And there are two main ways to go about this:
Okay.
active and passive fingerprinting.
Okay.
So active fingerprinting is more like an interrogation.
All right.
You send specific probes to the target, and then you analyze the responses.
Oh, okay.
And this is where tools like Nmap come in.
So you're like giving it a tap on the shoulder and seeing how it reacts.
Yep, that's a perfect analogy.
Okay.
Passive fingerprinting, on the other hand, is more like surveillance. You're observing
Okay.
existing network traffic without directly interacting with the target.
So kind of like blending in and picking up clues
Precisely.
from the existing chatter.
Exactly.
Okay.
So both approaches have their own pros and cons, but the goal is the same.
Right.
You want to figure out what operating system is running on that computer
Right.
from its network behavior.
Okay, so let's dig into the methods themselves.
Okay.
Our sources talk about IP-TTL values, uh, TCP window sizes,
Mhm.
and all sorts of other network characteristics. It's like a whole alphabet soup of stuff.
It is. It really comes down to understanding
Yeah.
the nuances of network communication protocols.
Okay.
Each little detail can tell you something
Right.
unique about the operating system.
It's not just about speaking the language, it's understanding the accent.
I like that. Yeah, that's a great way to put it.
Okay, so
So, for example, the IPTTL, the time to live,
mhm.
it's basically a countdown timer for data packets.
Right.
And every time a packet hops through a router, this timer gets decremented by 1.
Okay.
And different OSs tend to set this initial TTL value
Okay.
to different numbers,
Yep.
which can be a subtle but detectable trace.
It's kind of like a breadcrumb trail that fades with each step.
Exactly.
Okay, cool.
What about IP ID values?
Yeah, those are it seems like each packet has its own little serial number.
Yeah, you got it. You got
And
it.
you can track those.
And by looking at the patterns
Right.
of how these ID values
Yeah.
are generated and incremented, that can
Yeah,
also
the OS.
give her the OS. Yeah.
So spotting a pattern in someone's handwriting.
Exactly. Exactly.
Okay.
Then you've got the TCP window size,
Right?
which dictates how much data a device can receive at once.
Okay.
It's like a data appetite.
Okay.
Different OSs have different appetites.
So some are like ravenous and some are nibblers.
That's a good way to visualize it.
Okay.
And then you've got TCP options and flags.
Right.
These are extra settings within the TCP packets
Okay.
that can act like little unique fingerprints
Right.
that further refine our OS detection capabilities.
So we've got TTLs, IPIDs, window sizes, flags. Yeah.
It's like every little twitch and gesture can be a clue.
It is. It's amazing how much information leaks out of these network communications.
Right. And our sources also mentioned DHCP, ICMP, even things like MDNS and UPnP.
Oh, yeah. Tons of stuff.
Yeah.
But remember, relying on just one technique
Right.
can be misleading. It's
Yeah.
like a detective needs
Yeah.
multiple sources to build a case.
Right, right.
Got to look at the big picture.
Okay, so let's move on to a specific tool.
Okay.
Nmap, this seems to be like the big kahuna of active fingerprinting.
Oh, absolutely. It is a powerhouse.
Okay.
Loved by security professionals and anyone who's curious about what's lurking on their network.
So Nmap is like the digital equivalent of a really skilled interrogator.
Yeah.
It's not passively observing, it's sending out these very specific probes
That's right.
to get a response.
Sends out TCPs, ECM probes, all sorts of things,
Right.
just to kind of knock on different doors and see who answers and how they answer.
And our sources really dig into the details of this.
Oh, yeah.
It's not just about sending these out, it's how they're timed.
Yes.
It's how the options, how the flags are set.
It's like a little conversation with
Yeah.
the target system.
It's a dance.
Exactly. And Nmap leading.
Right.
Yeah, it's fascinating.
So Nmap is building this profile piece by piece
Yes.
based on how the target reacts.
Precisely.
And then it compares that to its database, that massive database of known OS fingerprints.
Right. The Nmap OS DB.
Yeah, it's like having a giant fingerprint database
It is.
for operating systems.
Constantly being updated, constantly being refined.
Right. And some of the details
Yeah.
in this database, from what I understand, it's not just the OS.
Right.
Sometimes it can even identify specific hardware models.
Yeah. Depending on how the network stack
Wow.
behaves.
That's crazy.
It's those little nuances that make OS detection so powerful, but also so challenging.
Right.
You know, operating systems are always evolving.
Constantly.
Yeah. And so are the techniques.
Used to fingerprint them.
It's a constant game of cat and mouse.
Oh, absolutely.
Okay, so we've talked a lot about Nmap, but it's not the only tool out there.
No, not at all.
We've got things like Network Miner, P0F, Satori.
Yeah, each tool has its own strengths and specializations.
Yep.
Some are better at passive fingerprinting.
Mm-hmm.
Some are known for their analysis capabilities
Okay.
or their fingerprint databases.
And speaking of databases,
Yeah.
there's something really cool about the P0F.FP database,
Okay.
which is used by POF.
Right.
It's not just a collection of fingerprints. It's organized. It's got this whole label system
Mhm.
that tags each fingerprint with information about its type
Right.
and the class of software.
Yeah. Makes it really efficient
Right.
to search and analyze.
Exactly. It's like a well-indexed library.
It is. It is.
And they even have this quarks field
oh, yeah.
that captures unusual behavior in network packets.
It's like a detective
Right.
noting a suspect's nervous twitch
Yeah.
or a peculiar way of speaking. You know, those little deviations from the norm can be very valuable
Right.
in distinguishing between very similar operating systems
Oh, wow.
or even pinpointing
Okay.
a specific version or configuration.
But like we've been talking about, OS detection isn't a perfect science.
No, it's not.
There are definitely some challenges.
There are.
Limitations to keep in mind.
Absolutely.
One of the big ones that our sources mention is the constant evolution of operating systems.
Right. It's like trying to hit a moving target.
Yeah.
Developers are always updating, patching,
Right.
improving security.
So what we might know today might be outdated tomorrow.
Exactly.
And then there's things like firewalls.
Yes.
The NAT devices that can kind of mess things up.
Yeah, they could obscure those telltale fingerprints.
So it's like trying to identify someone who's wearing a mask.
Exactly.
Okay, yeah.
And then, of course, there's OS spoofing.
Right, where somebody's trying to deliberately throw you off.
Yeah, putting on a digital disguise.
Right, so you can't just rely on OS detection alone.
No, you can't.
You need other sources.
Multiple sources of evidence.
Right.
Like any good investigation.
And a healthy dose of skepticism.
Always. Always.
Okay, so we've covered a lot of ground here
Yeah, we
in
have.
this first part of our deep dive.
It's a fascinating topic.
It really is.
A lot to unpack.
We've explored the what, the how, and even some of the challenges of
Yeah.
OS detection.
Yes.
But there's still so much more to uncover, right?
Absolutely.
Especially when it comes to the implications of this technology in the real world.
In the real world, yeah.
So we're going to take a little break,
Okay.
and we'll be right back to dig into all of that good stuff.
Sounds good.
All right, see you in a bit.
See you soon.
And we are back, folks. Man, my head is spinning after all that talk about OS detection techniques.
Yeah, it's a lot to take in,
It really is.
but it's it's really cool stuff.
It is.
And it's always evolving.
Yeah.
What was considered like super advanced a few years ago
Right.
might be completely useless now.
Yeah, it's a constant
Yeah.
back and forth.
Like a game of leapfrog
Right. Exactly.
between the people making the operating systems
Right.
and the people trying to figure out what they are.
Trying to catch them.
Exactly.
And speaking of different perspectives,
Mhm.
our sources actually brought up some interesting points
Oh, yeah.
about how reliable these techniques really are.
Yeah, that's a good point.
Yeah.
OS detection is powerful,
Yeah.
but it's not like 100% foolproof.
Okay.
There are definitely some limitations.
Okay, so give me the dirt. What can mess things up?
Well, for one, we talked about OS spoofing before.
Right. Right.
Somebody can deliberately
Yeah.
try to mask their true OS
Right.
and make it look like something else.
So, like, put on a digital disguise
Yeah,
to
exactly.
throw off the investigator.
Throw off those network detectives.
Exactly. Okay.
And remember, firewalls and NAT devices.
Yeah.
They can also make things tricky.
Okay.
They can obscure the real OS fingerprint.
Right, so you don't get a clear picture.
It's like trying to identify someone,
Right.
looking through a frosted window.
Oh, okay.
You can kind of get a sense of it,
Yeah.
but the details are fuzzy.
So should we just be skeptical of all OS detection results then?
Well, not necessarily.
Okay.
It's important to be aware of the limitations,
Okay.
but OS detection can still be a really useful tool,
Right.
especially when you combine it with other reconnaissance methods.
So it's all about context, right?
Context is key,
You can't just look at one thing.
and using a multifaceted approach.
Right, multiple sources.
Yeah.
Like we were talking about with the detective analogy.
Exactly.
Our sources also really stress the importance of keeping those fingerprint databases up to date.
Oh, yeah, absolutely.
Yeah.
Operating systems are constantly evolving,
Right, right.
so those databases
Yeah.
need to keep up.
Right.
Otherwise, you're working with old information.
Right, which could be completely wrong at this point.
Exactly. It's like using a map
Yeah.
from the 1800s
Uh-huh.
to navigate a modern city.
Yeah, you're going to get lost.
You're gonna get lost.
So constant learning is key here.
Oh, absolutely.
It's not just set it and forget it.
Not at all.
You got to stay on top of it.
Yeah. The most advanced techniques
Yeah.
go beyond just looking at what's in the packets.
Okay.
They might look at the timing of the responses,
Right.
the specific sequence of packets,
Okay.
even how the OS handles errors.
Wow. So it gets really detailed.
It does.
So there's like a whole spectrum of techniques
Yeah,
from basic to really complex.
absolutely.
Okay.
And it's not just about can we detect the OS,
Right.
but how confident are we in that detection?
Okay.
So the more sophisticated the technique,
Right.
the more reliable the results.
But probably harder to implement.
But yeah, more challenging to implement.
Okay, so it's all about trade-offs.
Trade-offs, yeah,
Picking the right tool for the job.
absolutely.
Okay, so we've talked about the limitations, the need for caution.
Yes.
But let's switch gears a little bit
Okay.
and talk about some real-world uses of OS detection.
Okay. Yeah.
Our sources had some really cool examples.
Oh, yeah. OS detection is used all over the place.
Okay.
Cybersecurity, network management.
Okay.
It's really a vital tool.
So like vulnerability assessment.
Yeah, for example.
I was reading about that. How does knowing someone's OS help you find weaknesses?
Well, every OS has its own set of known vulnerabilities.
Yeah.
So if you know what OS
Yeah.
is running on a system,
Yeah, okay.
you can pinpoint
Right.
potential weak spots
Okay.
and then prioritize like your patching efforts.
So it's like knowing where the weak points are in a building,
Exactly.
you can focus your defense.
You can focus your defenses, yeah.
Okay, cool.
It's about being proactive,
Right.
addressing those security risks
Yeah.
before they can be exploited.
Before they become a problem.
Exactly.
And then there's incident response. Like
And-
if a security breach actually happens.
Somebody gets in.
Yeah. How does OS detection help there?
Well, if you know
Yeah.
what OS is running on that compromised machine,
Okay.
that can be really helpful in understanding
Yeah.
how the attacker got in
Right.
and what they might have accessed.
It's like a digital fingerprint at a crime scene.
Yeah, that's a great way to put it.
Uh,
Helps you trace back
uh,
to the culprit.
Cool. What else?
OS detection can also be used for network management.
Okay.
Think about it.
Yeah.
You can use it to identify unauthorized devices
On your network.
on your network, yeah.
Okay.
Or to track the usage patterns
Okay.
of different operating systems within your organization.
So you can kind of take stock of who's out there?
It's like taking inventory
Yeah.
of all your digital assets.
Making sure you know what's going on.
It's all about visibility
Right.
and control.
Okay.
And here's another one. You could use it to fine-tune
Okay.
your firewalls
Oh. Okay.
and intrusion detection systems.
How does that work?
Well, if you know
Yeah.
what the typical operating systems are
Right.
that are used in your environment,
Okay.
you can configure
Yeah.
your security systems
Okay.
to be extra sensitive
Right.
to anything suspicious
Okay.
coming from those OSs.
So it's like tailoring your defenses
Exactly.
to the specific threats.
Yeah, to what you're most likely to encounter.
Okay. That makes sense.
It's all about being smart
Right.
with your security.
Working smarter, not harder.
Exactly. And this is really just scratching the surface.
Right.
The information from OS detection
Yeah.
can be combined with other security measures.
Right.
And then you can leverage things like AI,
Okay.
machine learning.
To really take it to the next level.
Yeah, to really analyze
Right.
and understand what's going on.
So it's like a whole team of digital detectives working together.
It is. It's a collaborative effort
Yeah.
using the latest technology
Right.
to solve the case.
And the future of OS detection is probably going to rely on this even more.
I think so, yeah.
Automation, sophisticated analysis,
Yeah.
machine learning to find all those hidden patterns.
Absolutely.
So it's not just about knowing the OS anymore.
Right.
It's about understanding the bigger picture.
The behavior, the
The
context,
behavior, the
that's
context,
the potential risks, the
Yeah.
vulnerability.
connecting all the dots.
It's all connected.
Yeah.
And OS detection is a key part
Right.
of that puzzle.
Okay, so we've talked about the challenges. We've
Mhm.
talked about the applications.
Yes.
We've even touched on the future a little bit.
Yeah.
But there's one more thing
Okay.
that I really want to dive into,
All right.
and that's zero configuration networking.
Zero conf.
Yeah.
Interesting topic.
It seems like even in this world where everything's supposed to just work, it's automatic,
That-
right, Clay? Yeah, OS detection still plays a crucial role.
It does. It might seem counterintuitive,
Yeah,
but even when devices are supposed to connect
right.
without any configuration,
Yeah.
OS detection is still happening.
Okay, so how does that work?
So think about services like Apple's Bonjour
Okay.
or the open source Avahi.
Yeah.
They use things like multicast DNS
Mhm.
or MDNS
Right.
to automatically discover and announce services
Okay.
on a local network.
So even though I'm not manually configuring anything,
Right.
there's still a lot of communication happening in the background
There's a lot of handshaking going on.
to figure out what's what.
Yeah, and OS detection is a big part of that.
Okay.
It helps identify
Yeah.
what types of devices and services
Right.
are available.
It's like a digital concierge,
Uh-huh. That's a great way to put it.
figuring out who's who and what they can do.
Yeah, working behind the scenes.
Okay, so even in this configuration-free world,
Mhm.
OS detection is still there.
It is. It's essential.
It's essential. 'Cause-
Really underscores how important this knowledge is
Right.
in the digital age.
Yeah, and as we move toward more and more connected devices.
The Internet of Things.
Right.
Yeah, the need for this kind of automatic
Yeah.
but secure communication
Right.
is only going to become more important.
So it's not just for security professionals anymore.
No, not at all.
It's affecting everybody.
It's becoming increasingly relevant
yeah,
to everyday users.
whether they know it or not.
Exactly.
Okay.
OS detection is working behind the scenes
Yeah.
to make our digital lives
Yeah.
smoother, more secure,
Right.
more connected.
This has been really eye-opening.
Yeah, it's a fascinating topic.
I feel a lot more informed now
I'm glad to hear that.
about how this works.
It's all about understanding
Yeah.
the technology that shapes our world
Right.
and using that knowledge
Yeah.
to navigate the digital landscape.
Okay, so what's next on our adventure?
Well, we've covered a lot of ground,
We have.
but there's always more to learn.
There always is.
In the final part of our deep dive,
Okay.
we're going to take a step back
Right.
and consider the bigger picture.
Okay.
How's OS detection going to evolve?
Right.
What are the ethical considerations?
Right.
What does it all mean for us
Yeah.
as users, as citizens
Right.
in this digital world?
Okay, so the grand finale.
The grand finale. Yeah.
I'm excited.
Stay tuned.
Welcome back, everybody. We are in the final stretch of our OS detection deep dive.
Yeah, we've explored a lot of fascinating aspects.
We really have, from those super technical details
Mm-hmm.
to how it's actually being used out in the real world.
Yeah, from vulnerability assessments to incident response, network management, even zero configuration networking.
It's incredible how much OS detection is involved
It really is.
in everything we do online these days.
Kind of the invisible glue,
Yeah.
holding our digital world together.
And as we keep moving forward,
Yeah.
it's important to think about where all this is going.
Right.
How is it going to evolve?
Absolutely. One of the big things we're seeing is this shift toward automation and machine learning.
Yeah.
As these systems get more and more complex,
Right.
doing everything manually just doesn't get a cut it anymore.
So it's like we're going from the lone detective with the magnifying glass to like
Yeah.
a whole high-tech forensics lab.
Yeah, exactly.
Okay.
We're going to need powerful algorithms
No,
and machine learning models to
that's
sift through all this data.
Yes, there's so much of it.
There's just mountains of
Do
data.
we find those little subtle patterns?
Exactly. The
Yeah.
things that humans might miss,
Okay.
but AI can pick up on.
But with all this automation, are there any concerns about accuracy?
That's a valid point.
Yeah.
Anytime you rely on algorithms,
Right.
there's always a chance of bias creeping in,
Okay.
whether it's in the data used to train them or in the algorithms themselves.
So it's really important to think about how these systems are developed.
Absolutely. Transparency and accountability
Right.
are key here.
You don't want them to become like black boxes where you don't know
Exact.
what's happening
You
inside.
need to understand how they're making decisions.
Right. And make sure they're making fair decisions.
Right. And that brings up another important point.
Okay.
The potential for misuse.
Oh, yeah.
OS detection is a powerful tool.
Right.
It can be used for good,
Mm-hmm.
but it can also be used for bad.
So how could someone abuse this?
Well, imagine a hacker
Yeah.
who's using OS detection to find vulnerable systems.
Okay, so they're scanning a network.
Right. And once they know what OS is running,
Yeah.
they can target those specific weaknesses.
So it's like giving them a blueprint of your house
Yeah.
and saying, here's how to break in.
Exactly. They know exactly where the weak points are.
And it's not just individual hackers, right?
No, not at all.
This could be used by governments.
Nation states,
Yeah.
organized crime.
For spying, for sabotage.
Exactly. It's a very real threat.
So this really highlights the need for good security practices
Absolutely. Strong cybersecurity is essential.
and always be thinking one step ahead.
Yeah, it's a constant arms race
I'm right.
between the attackers and the defenders.
So what about the average person?
Yeah.
What can they do to stay safe?
Well, you might not be a cybersecurity expert,
Right.
but there are some simple things
Okay.
you can do to protect yourself.
Okay, like what?
Keep your software up to date.
Right. Those security patches are important.
They often fix
Yeah.
the very vulnerabilities
Yeah.
that could be exploited
Okay.
through OS detection.
And be careful about what information you share online.
Absolutely. Even little details
Yeah.
about your devices, your network setup,
Right.
could be useful to someone with bad intentions.
So think before you post.
Exactly. Be mindful of your digital footprint.
And if you're on public Wi-Fi,
Extra careful there.
public Wi-Fi can be a bit of a Wild West.
Right.
It's much easier for someone to snoop on your traffic.
So it's like you're having a conversation
Yeah.
in a crowded room.
Anyone could be listening.
Okay, so we've talked about the potential for misuse,
Mm-hmm.
but let's not forget the positive side of all this.
Right. OS detection can also be used for a lot of good.
It has the potential to really change things
Absolutely.
in so many areas.
From cybersecurity
Yeah.
to personalized user experiences
Imagine a world where your devices just work.
seamlessly.
Yeah.
They adapt to your needs.
Right.
Based on the OS you're using.
Your phone connects to your car.
Yeah.
Your laptop automatically sets up the printer.
It just works.
That would be amazing.
It would make our lives so much easier.
And from a security standpoint,
Yeah.
we could have systems that are way more resilient.
Right. They could automatically detect and isolate
Right.
any suspicious activity.
So it's like a digital immune system.
Uh-huh. I like that. Protecting us from all the nasty stuff out there.
Always on guard.
The possibilities really are endless.
They are. It's exciting to think about.
But we have to be responsible.
Absolutely. We have to use this technology wisely.
Wisely
Yeah.
and ethically.
And ethically, yeah.
Well, this has been quite a journey.
It has.
We've really gone deep.
Deep into the world of OS detection.
Yeah, we've covered the technical stuff,
Mm-hmm.
the real-world applications,
The future, the
your
challenges.
challenges, yeah.
It's been a lot of fun.
I feel like I have a much better understanding of
Me too.
how all this works and why it matters.
Hopefully our listeners do too.
Yeah, and hopefully they'll keep exploring this topic.
Absolutely. There's always more to learn.
There always is.
The digital world is full of mysteries.
And on that note,
Yeah.
we're going to wrap things up.
Okay.
Thank you all for joining us on this deep dive,
It's been a pleasure.
and we'll see you next time.
Until next time.